Section 7.5 talks about integration of inverse trigonometric functions. So we know the derivative of inverse sine of x is 1 over the square root of 1 minus x squared. I have an a in there. And we know the derivative of arctangent is arctangent of x is 1 over 1 plus x squared. I want to derive this for you so we can use it all throughout. This way you don't have to derive it every time. If this is what I am integrating, to match it with the derivative of inverse sine of x is 1 over the square root of 1 minus x squared, so I could go back. I'm going to factor out an a squared and that would be the integral of dx over the square root of 1 minus x over a squared, and that a right there comes out, so that's 1 over a, the integral of dx over the square root of 1 minus x. I don't like this x over a here. There. Now if I let u equal x over a, du will be 1 over a dx. So dx is simply a times du. So my u is right there. And my dx is really an a times du. Those cancel out. And this is nothing more than the inverse sine of u plus c, and if I substitute u back in, u was x over a, and there it is. Now we could use it without deriving anything. And similarly, if I take the integral of 1 over a squared plus x squared dx, what I'll do, I'll factor an a squared out, and the same idea as what we just did. Factor 1 over a squared out, that's dx over 1 plus, and if I make that x over a quantity squared, I would let u equal x over a, and du will be dx over a, which means that dx is a times du, and if I substitute my quantities in, I'm looking at the integral 1 over a squared 1 plus u squared, because that's my sub, and my dx will simply be a du. Here this cancels one of those, I'm left with 1 over a, and this integral is inverse tangent of u plus c, and that would be 1 over a, the inverse tangent, and my u initially was x over a, and I could use that from now on without deriving that as well. So if I look at some of the examples that help us with the homework, the first problem is really straightforward, not much to do. This is direct. The derivative of this will be, the integral of this will be simply the inverse sine of x plus c, because that's a 1 and it matches identically. No need to do any work whatsoever. On the next problem, I notice that's not a 1, but from what I've just learned, what do you square to get 9? That would be 3. So this is going to be the inverse sine of x over 3 plus c. No need to derive anything. You could always use that. And here, hopefully, we are really getting this u sub out of the way. the way I would work this out, I would say that's the integral of, and this is not a problem. Let's think about what this means. What do you square to get 16x squared? 4x. So if I really think about this, I'm going to say this is the inverse arc sine of what took the place of x? 4x divided by what do you square to get an 81 and 9? And what's the catch? If you remember, if this is linear, you simply, when you take a derivative, you multiply by that 4. When you take an antiderivative, you divide by that 4. That would be simpler than you using a u sub every time, because integration is going to become a bit longer. Now, just to show, I could have, instead of doing what I did, I could have said, well, let u equal 4x, du will be 4dx, and dx will be du over 4, and I'm going to show you this once. So this integral right here could have became the integral of the square root of 81 minus, and I sub for 4x u squared, and you notice dx is going to be replaced by du and a 1/4, so this will be 1/4 the inverse sine of u plus c. And what was u? U was 4x. So instead of doing all of this work, I've been trying to show you this. If this is linear, you could, when you take a derivative, you multiply by the 4. When you take an antiderivative, you divide by that 4. That will be a good way of really saving yourself the u sub every time. Otherwise, you're going to be doing that on most of the problems we're going to come across. And here, if I look at this, I notice that, you know what should I try in every problem? I should try a u sub. Do you notice that I don't need to go to arc sine, arc cosine? If I let u equal this, du is right there. So if I let u equal 1 minus 4x squared, du will be negative 8x dx. So, of course, you could let u equal just 4 minus x squared, but then you have to do another substitution. So if we could see this by now, we covered the u sub over and over. If you didn't really get it, you should review what we did before. X dx is right there, so divide by negative 8, and there it is. So this is not an inverse trig function. This is simply a u sub, and that would be a negative 1/8, and if you recall, that's u to the negative 1/2 du. Add 1 to the power, divide by that. That's u to the 1/2 divided by 1/2, that's multiplied by 2 over 1 plus c, and that turns out to be a negative 1/4 the square root of u plus c, and we know what u was. That was our sub right there. That was 1 minus 4x squared, and that'll do the trick. So this part D, again, you should look for u sub always. Same deal here. I notice if I let u equal 9 minus x minus the sine squared, du will be twice the sine of x dx. But I know by now, if I want a cosine, I should let u equal some form of a sine, and I have it right there. So my du will be the cosine of x dx. So that would be the integral of 9 minus, and if I replace the sine by a u, that's u squared, and du is nothing more than the top, and I know this is the inverse sine of u over 3 plus c, and that would be the inverse sine, and for now I'm not going to simplify this further, and there it is. So I use up something that's you really need to get out of the way. If I glance at this problem, I notice it has two parts. If I split it up, this part I know is arc sine, that's not a problem. And this part I know is just like example D. So here I'll get nothing more than 3 times the arc sine of x, done. Here I need a u sub. Let u equal 1 minus x squared. Du will be negative 2x dx. So my u is right there. And my du is really negative 1/2 du. So the answer is 3 arc sine of x minus 1/2. And we just did this problem right there. We know that's twice the square root of u. And we know what u is. U was 1 minus x squared. Of course, those cancel out, and that will be my final answer, and there it is. Now, if I get to a tangent, well, the same deal happens. The first problem is nothing more than a direct integration. What do you take a derivative of to get 1 over 1 plus x? Well, that's simply inverse tangent of x plus c. Done. And if I look at this by now, hopefully we're getting the hang of this u sub. We worked really hard at it. All what I have to do is make a small modification. What do you square to get 25x? 5x. So I know that this is going to be 1 over 3. Remember, the arctangent gets a 1 over whatever you square to get that number. The inverse tangent, and instead of x, it's 5x, but what do you do with that 5? Don't you divide by it? And that would be my answer. And of course, that's really 1 over 15, but there it is. That's good enough. And if I look at part I notice that it's not matching. But if I'm thinking of du, again, this is the key. What do you take a derivative of to get x? You take a derivative of x squared. If you let u equal x squared, du will be 2x dx. There it is. That's what I need. So we work backwards from now on. Now I need to make a small sub. So this is the integral. The 5 I leave alone. But if I replace x to the 4th, oops, not that color. What do you square to get x to the 4th? Well, that's x squared. I don't like that x. Nope. Let me make it bigger. There. So there's my u. And my du is really nothing more than x dx is nothing more than 1/2 du. And now it matches. Okay, I said it, but I didn't do it. That'll be my u, right? There. And now this is 1/2 times, what do you square to get 5? Radical 5. The inverse tangent of u plus c. It's really u over radical 5. And what was u? U was x squared. So you could write any number as a perfect squared by taking the square root of it. And what if I'm looking at a problem and it doesn't match at all? Well, that means I need to complete the square. I need to say that's, let's see, x squared plus 2x. I need to take half of the middle number and add it. That's 1. So the 5, if you take a 1 out of it, that's a 4. This becomes a 4 plus, and this is nothing more than x plus 1 squared. No need to make a u sub. This is really 1 over, what do you square to get a 4? A 2. The arctangent of whatever this is divided by 2 plus c. So you might have to complete the square on certain problems. This does come up. Everything we're doing, eventually you'll come across. And if I look at the last problem, the same deal happens. I'm looking at x squared minus 4x, minus 4x, and I'm thinking, what do you add to this? Well, half of this squared. Half of 2 is 2. Squared is a 4. If I have a 10 and I borrowed a 4 out of it, wouldn't I have a 6 left over? Wouldn't this become the integral of? And this is a perfect square, completing the square. Isn't that x minus 2 squared plus 6? So if I rewrite it just so that you could see it better, that's 6 plus x minus 2 squared. I could use a u sub, let u equal x minus 2 du will be dx, or I could save myself the time and say, you know what? All what I have to do is say that's the arctangent of x minus 2 instead of x. And what do we do with this? What do you square to get 6? That's the number that goes there, if you remember. And you square radical 6, of course. And that would be my final answer. If you want to use a u sub, you're welcome to do that. And that's pretty much what this section is all about.